Hello, my name is Ivan Adarin, and I will be presenting my project. My project involved using Python and using a convolutional neural network to be able to create speech recognition software. The reason why I chose a speech recognition is because it is one of the is like it is one of the most widespread technologies going on right now with all smart devices, and speech recognition, in my opinion, is probably a very revolutionary feature introduced to electronic devices today because it helps us interface with our electronics hands off and being able to use your devices hands off comes is very convenient both for people that tend to multitask and for people with disability. And so what I did was I found a website that provided me the code to help me start uh, be able to use a neural network in order to train the machine to recognize or to be able to understand audio files and interpret them. And the website I used was right here. It's called Analytics Vidya, and what I did was is it's an open source or he puts his code open source on GitHub, and I read this article and it allowed me to somewhat understand what goes into software recognition. And the steps for software recognitions involves getting a whole bunch of audio files, each one 1 second, and pre-processing them using a lot of uh, resizing and changing of wavelengths and frequency, which it's not too bad, but yeah, it was very hard to deal with. But anyway, once you get to pre-processing the audio files, then comes the part where you put it into the training data. For this project, I had to import Labrosa and SciPy, both of them which are used for audio processing. And as far as the actual neural network, the neural network involved, it was actually pretty straightforward itself. This is what the architecture looked like. I didn't change much of the code as far as architecture wise. So these images helps you see what actually happened or how the architecture actually went. So it came with an input and then four of these convolutional and max pooling layers, which if you look at the code right here, you can actually see there's one, two, three, four convolutional layers, and each one of them has a dropout in them, and we'll explain why it has dropout later. But yeah, each convolutional layer is activated by a ReLU function, which makes sense because we're trying to optimize uh, we're trying to optimize the audio files as much as we can because a lot of static tends to be involved in this data. But yeah, so 4 convolutional layers, flatten, and then more dropout. And yeah, once it goes through the training, it uh it was originally meant to go for like 100 epochs, but I had to change that because of time constraints. And if you can see here, or at least with my code, I changed like this code gave me a lot of difficulties because the samples were like large. They were maybe in like the thousands range, and it took a very long time to train. But that was really the most time consuming part. But anyway, I had to narrow it down to, let's see, I had to narrow it down to, I believe it went from 100 to 30 epochs. Because around the 30 range, that's when we get these numbers. And I was hoping that those numbers would help me gain some sort of accurate data. But it didn't seem like that was the issue because I still kept running into other problems. And and yeah, here's the graph for the sample and training data. Each one of these are 1 second audio files, but they were about, oh wow, that's a lot. Let's just say there was a lot of audio files to go through, and that was probably my first mistake, was having that much training data. So anyway, back to the network, or the neural network, I should say. And after it was trained, I had to save the model or to save the model right here. And after it gets saved, I'm supposed to use my own audio files to see if I can get the model to predict what I'm saying. But like I said, I never got to that point because there was an issue there was an issue with my code somewhere down here. Because I was trying to bypass this part where it prompts me to make my own voice commands, and I was trying to jump straight to this part. What I was trying to do is uh, do what this video clip here shows, which is where he plays the video clip, and then which he plays a audio clip where he says off, and then the machine or the code like predicts what he said and it says off, but I was never able to get to the point where I could get that part to work. So because of that, my results aren't, oh, I have no results to actually show off. All I can say is that I was able to train the data, but I have no verification for that. So yeah, and because of that, uh, my findings are minimal, and I can't really say that I've this project is a success.